Imagine stepping out of your front door, not onto a familiar street, but onto the surface of another world. Our solar system is a vast and varied neighborhood, filled with planets and moons that are both beautiful and incredibly dangerous. Each one offers a unique set of challenges, a cosmic test of survival. What would it really be like to stand on these alien landscapes? Without the comforting blanket of Earth's atmosphere and magnetic field, a human would face instant death almost everywhere we look. But what if we had the most advanced spacesuit imaginable, a personal spacecraft to protect us? How long could we last then? This journey is not just about survival times, it is about understanding the immense forces that shape our cosmic backyard. The dream of walking on other worlds is as old as humanity itself. We have looked up at the stars and planets as points of light, imagining what wonders they hold. Now, through the eyes of our robotic explorers, we have begun to see them up close. We have seen the rusty deserts of Mars, the acid clouds of Venus, and the icy plains of Pluto. These missions give us the data we need to ask these questions seriously. They tell us about the crushing pressures, the searing heat, the bone-chilling cold, and the invisible storms of radiation that rage across the solar system. By exploring what it would take to survive, even for a few minutes, we learn more about what makes our own planet so precious and unique. This exploration is not just a thought experiment, it is the very foundation of our future in space. Every piece of information we gather, from the temperature on Mercury to the wind speed on Neptune, helps us design better technology. It informs our plans for sending humans back to the moon and then onward to Mars. Understanding the dangers is the first step toward overcoming them. It pushes us to innovate, to create materials that can withstand unimaginable conditions, and to build habitats that can sustain life far from home. This journey through the solar system is a story of human curiosity, ingenuity, and our relentless drive to explore the unknown. So, let us begin our grand tour. We will travel from the sun-baked inner planets to the frozen outer reaches, stopping at each major world along the way. For each location, we will ask the same simple questions. What would it feel like to be there? What would be the first thing to kill you? And with the best technology we can dream of, how long could you witness these alien vistas before they claim you? This is a cosmic challenge, a test of the limits of human endurance and technology. It is a journey that will show us just how hostile the universe can be, and yet, how it might one day become our home. Our first stop is Mercury, the planet closest to the Sun. Standing here is a lesson in extremes. The Sun in the sky would look 3 times larger than it does from Earth. A blinding white orb in a black, airless sky. Mercury has almost no atmosphere to scatter sunlight or hold on to heat. This means the temperature difference between day and night is shocking. If you stood on the side facing the Sun, you would be baked by temperatures of 427 degrees Celsius, hot enough to melt lead. But if you stepped into a shadow, or onto the night side, the temperature would plummet to a freezing minus 173 degrees Celsius. Without a suit, you would die in less than 2 seconds, either flash fried or flash frozen, while the lack of air pressure would boil the liquids in your body. Now let's give you a futuristic spacesuit. This suit would need powerful cooling systems to fight the heat and heavy insulation to fight the cold. It would also need thick shielding against the sun's intense radiation. Even with all this technology, your survival time would be short. On the sunlit side, the sheer amount of solar energy would eventually overwhelm your suit's cooling system. You would overheat and your life support would fail. You might last about 15 minutes before succumbing to heat stroke and organ failure. The relentless radiation would also degrade your suit's electronics. Probes like Messenger, which orbited Mercury from 2011 to 2015, had to use a special sunshade to survive, giving us a hint of the challenges involved. Next, we travel to Venus, Earth's so-called twin. This name is terribly misleading. Venus is a vision of hell. The planet is wrapped in a thick, toxic atmosphere of carbon dioxide, creating a runaway greenhouse effect. The surface temperature is a uniform 470 degrees Celsius, even hotter than Mercury, making it the hottest planet in the solar system. The atmospheric pressure is over 90 times that of Earth's. Standing on Venus would feel like being nearly a kilometer deep in the ocean. Without a suit, you would be simultaneously crushed, cooked, and choked in an instant. Your end would come in less than a single second. Surviving on Venus in a spacesuit would be an even greater challenge than on Mercury. Your suit would need to be built like a deep-sea submersible to withstand the crushing pressure, but also have refrigeration powerful enough to handle the oven-like heat. The Soviet Union's Venera 13 probe, which landed on Venus in 1982, was a marvel of engineering. It was a titanium sphere designed to survive, and it lasted for a record 127 minutes before it was destroyed. A human in a suit based on that design would face a similar fate. The first thing to fail would be the cooling system, leading to a quick death from heat stroke. Then the suit itself would be dissolved by the sulfuric acid clouds and finally crushed by the immense pressure. Your heroic visit would likely last no more than 20 minutes. After the infernos of Mercury and Venus, Mars seems almost welcoming. This is the world that has captured our imagination more than any other, the prime candidate for a second home for humanity. The Martian landscape is a cold, dusty desert under a thin, pale orange sky. The gravity is only about 38% of Earth's, so you would feel light on your feet, able to jump much higher than you could at home. But do not be fooled by its familiar appearance. The atmosphere on Mars is 100 times thinner than Earth's and is mostly carbon dioxide. Without a spacesuit, the low pressure would cause your blood to boil, and you would suffocate from the lack of oxygen. You would survive for less than 2 minutes. With a proper spacesuit, however, the story changes dramatically. A suit on Mars would need to provide oxygen, warmth, and protection from solar radiation, which is much higher than on Earth due to the thin atmosphere. Temperatures can be quite comfortable at the equator during the day, reaching up to 20 degrees Celsius, but at night, they can drop to a frigid -70 degrees Celsius. Your suit's heater would be working hard to keep you from freezing. Unlike on Venus, the pressure is not a major structural problem. With a full tank of oxygen, you could explore the red planet for as long as your supply lasts, perhaps for about 10 hours, before needing to return to your habitat to recharge. The dangers on Mars are more subtle and long-term. The fine, abrasive Martian dust could get into equipment and cause it to fail. We have seen this with our robotic explorers. The wheels of the Curiosity rover were damaged by sharp rocks in 2022, and dust storms can cover solar panels, cutting off power. The biggest long-term threat is radiation. Without a thick atmosphere or a global magnetic field to protect it, Mars is constantly bombarded by cosmic rays and solar particles. This radiation can damage human DNA and increase the risk of cancer, making long stays on the surface very dangerous without significant shielding. This is why future human missions like those envisioned by SpaceX and NASA focus on building protected habitats. Elon Musk has famously predicted that a city of 1 million people could exist on Mars by 2050, transported by the massive Starship rocket. These first Martians would not be living out in the open. They would likely live in underground lava tubes or in habitats three-dimensional printed from Martian soil, perhaps covered by a thick layer of ice for radiation protection. They would grow food in hydroponic farms and generate fuel from Martian water ice and atmospheric carbon dioxide. Mars is not a paradise, but with our ingenuity, it is a world we could learn to call home. Now we venture into the outer solar system where the gas giants rule. Our first stop is the king of planets, Jupiter. There is no surface to stand on here. Jupiter is a colossal ball of gas, mostly hydrogen and helium. If you were to attempt a descent, you would simply fall through its endless layers of clouds. Your journey would be short and violent. Without a suit, the lack of oxygen and extreme cold of the upper atmosphere would kill you instantly. But even in the most indestructible suit imaginable, your plunge into Jupiter would be a terrifying ride lasting only about 3 minutes. The killer here would not be pressure or temperature at first, but the wind. As you fell into Jupiter's atmosphere, you would pass through clouds of ammonia ice at -100 degrees Celsius. Soon after, you would hit the main cloud deck, where you would be tossed about by winds reaching nearly 600 kilometers per hour. These winds are so powerful that the G-forces would be catastrophic, tearing your suit and your body apart. If you somehow survived that, the pressure and temperature would rapidly increase. In 1995, the Galileo probe plunged into Jupiter's atmosphere and survived for 58 minutes, transmitting data until it reached a point where the pressure was 24 times that of Earth, and the temperature was 150 degrees Celsius. Your suit would be crushed and melted long before you reached any solid core, assuming one even exists. Near Jupiter lies one of the most fascinating moons in the solar system, Europa. This world is a frozen wasteland, covered in a shell of water ice that is estimated to be 15 to 25 kilometers thick. Beneath this ice lies a vast, dark, liquid water ocean, warmed by the tidal forces of Jupiter's immense gravity. The surface temperature is a constant minus 150 degrees Celsius. Unprotected, you would freeze solid in seconds. But the biggest danger on Europa is not the cold, it is the radiation. Jupiter's magnetic field is 18,000 times stronger than Earth's, and it traps a donut of deadly radiation that constantly bathes Europa. In a spacesuit, you could walk on Europa's icy surface, a surreal landscape of cracks and ridges under the watchful eye of the colossal Jupiter in the sky. However, the intense radiation would be your downfall. It would quickly fry your suit's electronics, disabling your life support systems and oxygen supply. Your vision would be obscured by flashes of light as high-energy particles pass through your eyeballs. Even with heavy shielding, your time would be limited. You might survive for about 15 minutes before your suit fails and you succumb to the lethal radiation. The true promise of Europa lies beneath the ice, where its hidden ocean may harbor life, but the surface is one of the most hostile places imaginable for a human. Leaving the deadly realm of Jupiter, we arrive at the jewel of the solar system, Saturn. Famous for its magnificent rings, Saturn is another gas giant, slightly smaller than Jupiter but no less hostile. Like Jupiter, it has no solid surface to land on. A journey into its atmosphere would be a one-way trip into oblivion. The upper atmosphere is a frigid minus 200 degrees Celsius, cold enough to make any material brittle. As you descended, you would encounter the solar system's fastest winds, which can reach speeds of up to 1,800 kilometers per hour. These winds would batter your suit relentlessly. Without protection, you would freeze and suffocate instantly. Even with a hypothetical supersuit, your survival would be measured in mere minutes. The extreme cold would weaken the integrity of your suit's materials, making it vulnerable. The hurricane-force winds would then inflict physical damage, while the pressure would steadily increase, looking for any weakness to exploit. Eventually, the combined forces of cold, wind, and pressure would cause your suit to deform and implode. You might get to witness the beautiful yellow-hued ammonia clouds up close, but your journey would likely end after about 5 minutes. Saturn is a world best admired from a great distance, its beauty masking an incredibly violent interior. But orbiting Saturn is a world that offers a completely different and tantalizing experience. Titan. This is the largest moon of Saturn and the only moon in our solar system with a thick atmosphere. In fact, its atmosphere is 50% thicker than Earth's and is mostly nitrogen, just like ours. The pressure at the surface is about 1.5 times that of Earth, meaning you would not need a pressurized suit. The thick atmosphere also provides excellent protection from cosmic radiation. The main problem on Titan is the cold. The surface temperature is a bone-chilling minus 180 degrees Celsius. You would also need an oxygen mask to breathe. If you were properly dressed in a heavily insulated suit and had a supply of oxygen, you could survive on Titan for a surprisingly long time. Your limit would be the effectiveness of your suit's heating system. Against the constant, extreme cold, your power source would eventually run out, and hypothermia would set in. But you could potentially explore for 2 or 3 hours. And what an exploration it would be. Titan has a landscape of dark dunes made of solid hydrocarbons, and lakes and rivers filled with liquid methane and ethane. The gravity is only 1/7 of Earth's, and combined with the thick atmosphere, you could actually fly by strapping wings to your arms and flapping. Our journey now takes us to the far reaches of the solar system, to the mysterious ice giants, Uranus and Neptune. These worlds are smaller than Jupiter and Saturn but are still massive globes of gas, ice and fluid. Uranus is a strange, tilted world, orbiting the sun on its side. Its atmosphere is the coldest in the solar system, with temperatures dropping to minus 220 degrees Celsius. If you were to plunge into its blue-green clouds, you would face this extreme cold combined with winds of up to 900 kilometers per hour. As with the other gas giants, there is no surface to stand on, only a descent into crushing pressure. Without a suit, your end would be instantaneous. In a highly advanced suit, your survival time would be minimal. The primary threat would be the intense cold, which would make your suit's materials extremely brittle and prone to catastrophic failure. The powerful winds would add to the stress, battering you as you fell deeper into the planet. It would be a race to see what kills you first, your suit shattering from the cold, being torn apart by the winds, or being crushed by the rapidly increasing pressure. Your spectacular but brief journey into Uranus would likely last no more than 3 to 5 minutes, a fleeting glimpse into a frigid, turbulent world. Next is Neptune, the last true planet in our solar system. It is a deep blue world, racked by the most violent weather we have ever seen. Neptune holds the record for the fastest winds in the solar system, with supersonic gusts reaching an astonishing 2,100 kilometers per hour. The temperature in its upper atmosphere is a frigid -200 degrees Celsius. The combination of these extreme factors makes Neptune arguably the deadliest of all the gas giants for a human explorer. A person without a suit would be flash frozen and torn to shreds in a fraction of a second. Even in our imaginary perfect spacesuit, a trip to Neptune would be suicidal. Your survival time here would be even shorter than on the other gas giants, estimated at just 2 minutes. The moment you entered the atmosphere, you would be hit by winds faster than the speed of sound. The sheer force would be like being hit by a continuous explosion. This, combined with the extreme cold and rapidly building pressure, would overwhelm any conceivable technology. Your suit would be ripped apart almost instantly. Neptune's violent beauty, with its great dark spots and wispy white clouds of methane ice, is a spectacle meant to be viewed only from the safety of a distant spacecraft like Voyager 2, which flew by in 1989. Our final stop on this perilous tour is Pluto, the most famous of the dwarf planets, which orbits in the cold, dark expanse of the Kuiper Belt. When the New Horizons probe flew past in 2015, it revealed a world of stunning complexity and beauty. We saw vast plains of frozen nitrogen, towering mountains of water ice, and a thin, hazy atmosphere. The surface of Pluto is one of the coldest places in the solar system, with temperatures hovering around -220 degrees Celsius. The gravity is very weak, similar to Earth's moon, so you would feel light and buoyant. The sun from this distance would appear as just a very bright star, casting a dim, eerie twilight over the frozen landscape. Without a spacesuit, the extreme cold would freeze you solid in a matter of seconds. The thin atmosphere, while present, offers no breathable air and very little pressure, so the liquids in your body would boil away. But what if you had a suit designed for this incredible cold? Your primary challenge would be staying warm. Your suit would need a powerful and long-lasting heating system to fight off the relentless deep freeze temperatures. The thin nitrogen atmosphere does offer a tiny bit of protection from radiation, more than on an airless moon, but not by much. Still, it is a factor that makes Pluto slightly less hostile than some other frozen worlds. The main danger on Pluto for a suited astronaut comes from the effect of the extreme cold on technology. At such low temperatures, materials become very brittle. A small impact from a micrometeoroid or even a clumsy fall could potentially crack your helmet or breach your suit. A sudden depressurization would be instantly fatal. Assuming your suit remains intact and your heater functions perfectly, you could survive for a while. However, the constant battle against the cold would drain your power supply quickly. A realistic survival time might be around 8 minutes, limited by the risk of your suit becoming brittle and failing catastrophically. Exploring Pluto would be a surreal experience. You could walk across the vast, flat nitrogen ice sheet known as Sputnik Planitia and gaze up at Pluto's largest moon, Charon, which hangs motionless in the sky because the two worlds are tidally locked. You would be standing on a world at the edge of our solar system, a place we once thought was just a simple ball of ice and rock. Instead, we found a dynamic and active world, a frozen heart still beating in the darkness. It is a testament to the endless surprises the cosmos has in store for us, a final, beautiful, and deadly stop on our journey. Surviving in the hostile environments of our solar system is not just about human endurance, it is a problem of technology. The spacesuit is the most personal and critical piece of equipment, a tiny human-shaped spacecraft. Today's suits, like the ones used on the International Space Station, are designed for the vacuum of space, not for the crushing pressures of Venus or the extreme winds of Neptune. A suit for planetary exploration would need to be a hybrid of a spacecraft and a deep-sea submersible. It would require layers of insulation, powerful heating and cooling systems, robust radiation shielding, and an exoskeleton strong enough to withstand immense forces, all while being flexible enough for an astronaut to move and work. We learn how to build these future technologies from our robotic pioneers. The Soviet Venera probes that landed on Venus were built like tanks, with titanium hulls and layers of insulation, teaching us about survival in high-pressure, high-temperature environments. The Galileo probe's descent into Jupiter gave us priceless data on the behavior of gas giant atmospheres. The Curiosity and Perseverance rovers on Mars are testing materials and power sources, like the radioisotope thermoelectric generator, which provides steady power regardless of dust storms or nighttime, a crucial technology for future human habitats. Every probe we send is a scout, testing the dangers so that one day, we can follow. For long-term survival, a spacesuit is not enough. Humans will need to build habitats, small bubbles of Earth in alien landscapes. On Mars, the leading ideas involve using the planet's own resources. NASA's 3D printed habitat challenge explored concepts like the Mars Ice House, a multi-story structure printed by robots and covered in a thick layer of water ice to shield inhabitants from radiation. Lava tubes, natural underground tunnels formed by ancient volcanic activity, could provide pre-made shielded shelters on both the Moon and Mars. These habitats would be self-sustaining ecosystems, recycling air and water and growing food in advanced agricultural modules. Beyond Mars, our ideas for colonization become even more imaginative. For Venus, a planet with a hellish surface, NASA has proposed a concept called Havoc, or High Altitude Venus Operational Concept. This plan involves floating airships like Zeppelins that would drift in the upper atmosphere of Venus, about 50 kilometers up. At this altitude, the temperature and pressure are surprisingly Earth-like. Colonists could live and work in these cloud cities, studying the planet below from a safe distance. On a world like Titan, with its low gravity and thick atmosphere, habitats could be lightweight domes, and humans might one day use personal flight devices to explore the hazy, orange world. These concepts show that with enough creativity, we can imagine a future for humanity almost anywhere. Our tour of the solar system reveals a stark and humbling truth. Earth is a rare and precious sanctuary. It is the only place we know of where a human can walk outside without a suit and survive for more than a few seconds. Every other world presents a lethal combination of extreme temperatures, crushing or non-existent pressures, toxic atmospheres, and deadly radiation. Venus would crush and cook us, Jupiter would tear us apart with its winds, and Pluto would freeze us solid. The universe is not designed for us. It is a vast, indifferent, and dangerous place. Our survival depends entirely on the thin, fragile shell of our planet's atmosphere. And yet this tour also fills us with a sense of wonder and possibility. The same laws of physics that create these deadly environments also create breathtaking beauty: the rings of Saturn, the canyons of Mars, the icy plains of Europa, and the hazy skies of Titan. Understanding these worlds is part of our cosmic journey. It satisfies our innate curiosity, our need to know what lies over the next hill, or in this case, on the next planet. This drive to explore has taken us from the plains of Africa to every corner of our own world, and now it is pulling us toward the stars. The challenges of surviving on other planets force us to be our most ingenious selves. To live on Mars, we must master recycling, renewable energy, and sustainable agriculture. To build habitats on the Moon, we must develop advanced robotics and new construction materials. The technologies we invent for space exploration often have profound benefits back on Earth, from medical imaging and water purification to GPS and wireless communication. The quest to become a multiplanetary species is not an escape from Earth's problems, it is a catalyst for solving them. It is a grand challenge that pushes the boundaries of science and engineering. So, what is our future in the cosmos? We are currently wanderers, taking our first tentative steps away from our cradle. We send robotic probes as our eyes and ears, and we dream of the day when we will follow. The journey from wanderer to settler will be long and difficult. It will require international cooperation, incredible technological leaps, and a generation of brave explorers. But it is a journey that is fundamental to our nature. One day, our descendants may look up at the sky from the red soil of Mars, or from a floating city in the clouds of Venus, and they will see a faint blue dot. They will call it their ancestral home, knowing that the journey from that single, fragile world was the greatest adventure in human history.